introduce today's session with the BioBuilder Educational Foundation. BioBuilder was founded at MIT, and it's been bringing hands-on synthetic biology and biotechnology into classrooms since 2011, reaching tens of thousands of students and teachers worldwide. Today, we'll hear from Dr. Natalie Coldell, BioBuilder's founder, who will share how their kits and the new biotech builder. I'm sorry, that's a little tongue twister. I'm sorry. Curriculum, it translates real lab skills into classroom-ready lessons. A curriculum that recently earned an Educator's Choice Best of STEM award. Joining her is Char Montgomery, a longtime educator with a deep passion for teaching science, who brings practical classroom experience to how these materials work with students. Expect concrete examples you can adapt immediately and evidence to impact on both teaching and student pathways into biotech. Welcome, and thank you for being here.
It's a delight. I am very excited to be able to chat today and really thrilled to be able to share the stage with Char Montgomery, one of the most wonderful teachers I've gotten to meet in Tennessee. So the way I would like to run this is I'll share my screen for a smidge, and I have some slides to run through. Hopefully you can see my screen now, and I will run through these slides. They are broken up into really three sections. The first is why BioBuilder is here and what we're hoping to do with it. The second is about some of the programs that we offer and some of the examples and things we've learned from running those programs. And then the third is to talk about the model that we have found for implementation in Tennessee, which is truly remarkable. And Char is teaching in Tennessee and can speak to what it looks like there and what we've done. And then the last part, which I didn't start with, but was to say that I'd be very eager to have your questions along the way. I'll pause between each of those sections and ask for questions, but please do drop them in the chat, or between the times we can come off mute and clarify or correct what I have said. So let me get started by talking about BioBuilder and what it is we are hoping to do. Actually, let me advance this. This gives you the high school that Char is from, lists my name and spelling, and some of the key messages that I'm hoping to get across with this webinar, which is that high quality public education in life science is really going to enable broad participation in the bioeconomy, which is a big motivator for economic growth around the world, and certainly in the US this century. We have two curricula, BioBuilder and Biotech Builder, and I'll explain a little bit about both of them, and that they can coordinate into a national model for science education that can overcome checkpoints that currently exist. And then throughout, I hope you'll see that bioliteracy is a national security issue, and that science identity is really essential for workforce development initiatives to succeed. And so I think BioBuilder plays an important role in both of those realms, bioliteracy and developing of a science identity in young people. So I'm going to start in a hometown place for me, and if I can't imagine anybody, maybe somebody on the line is from Boston, in which case please drop it in the chat and say hi from which town you're in. But this is a picture of Boston's Palace for the People, our Boston Public Library. And just before this webinar, I looked up a couple of fun facts about our library, which I love. It was the first large library. It was the first library to lend books, and it was the first one with a children's room, which I thought was surprising. It was built in 1888. It took until about 1895 to complete. It gets about 6 million visitors a year. And on one of the sides of our beautiful Boston Public Library, it says this. It says the Commonwealth, our Commonwealth of Massachusetts, requires the education of the people for the safeguard and order of liberty. So really foundational to Boston and to actually our country as a whole is the idea that education of the people is essential for our well-being, for our security, and for our success, our development, economic, and well-being. So education is baked into our work as a country, and we are in some measures doing a really great job educating our citizenry. This is a graph of educational attainment around the country. Starting back in 1960, where it was about 7% of our country had graduated from a bachelor's degree from university or higher. And about 40% were graduating from high school. Fast forward now to the 2020s, and you have about 40% of our country graduating from college or more, and about 90% graduating from high school. And on one level, you can look at this and think that is the most incredible success story in education that you would imagine. Both of those curves are so significantly up and to the right. On the other hand, you can look at this chart and also think that it is a great failure of our educational work because although 4 out of 10 of our country graduates from college or more, 6 out of 10 are not. And we have for many years now said that college is for everyone and that the quality jobs, the wealth building jobs are for college students. And so I think we have left behind a number of students throughout the country who graduate from high school but do not, maybe should not, maybe don't want to go to and complete college. The flip side to that is to look at the student's voice. And when the Walton Family Foundation and Gallup ask the young people who are in high school now how they are feeling, that despite the challenges they face, they remain hopeful about their future, but they feel quite unprepared for it. Many say that school does not provide many hands-on STEM experiences for them. And the flip side to that, of course, is that students are much more likely to pursue science, technology, engineering, and math careers if they encounter topics in school and get excited about them. So we have a large number of students that I think we can do better for. And it's important that we do think about the high school students because if you start to focus on the college students exclusively, what you see is that of those 40% that go to college, a third of them end up majoring in STEM. So you go from 4 out of 10 of the population going to college, and then only a third of them going into STEM fields. And then when they graduate, only half of those go and work in STEM. So you have an ever diminishing pipeline of individuals who are committed to college and careers in science, technology, engineering, and math. So from the industry side, this presents an issue because there are many jobs. This is data from Massachusetts again, from just this past summer, which says that half the jobs are available that are advertised this past year were available to students with bachelor's degrees, about 15% to PhDs or higher. But there is another 15% of the jobs that are for high school students and students with associate's degrees. So there are as many jobs for PhDs and for students who have high school and associate's completion. So I think this is an underappreciated sector of individuals with talent who really are needed for our STEM pipeline. And who, from that Gallup poll and the Walton Family Foundation, really seem to be eager to engage in different ways while they are in high school. BioBuilder's been around since 2011, and I'll give a little bit of a history about our organization, our nonprofit. But some of the students that we trained early on have now gone on to college and careers. One of them is this young man, Kevin Fuentes, who was introduced to BioBuilder while he was in high school. And you can see that what he said is that, with exposure to quality science education experiences in high school, it was the first time he imagined himself as a scientist, right? And could see himself as capable in that capacity. Similarly, we have gal Angel, who similarly thought while she was doing this work, while she was in high school, that she was becoming a scientist. And all of a sudden, she sort of realized that this was something she liked and something she wanted to do more of. So there is a need and a power in addressing science and science identity, science skills, quality science education at the high school level. And I think it is underappreciated, but maybe not in this crowd, but generally speaking, I think that is true. So BioBuilder really was established to build a better world by educating more people in the life sciences. We develop life science curriculum that delivers these relevant knowledge and skills that make students prepared for college and careers in science. We do it in a way that excites the students to pursue these educational opportunities. And we are particularly focused on students who face societal barriers to either access college or for career opportunities in life science. Many of our students don't have parents who are also scientists, right? We also, and my board always reminds me to say this, and hopefully Char will back me up on this when she speaks about her implementation of this. We try to make it fun. We try to make these science experiences fun for the students, and it's approachable for both the students to do and for the teachers to teach. So in the process of all this, the students are discovering new ways to think about life science and to pursue careers in this field. And they're exposed to a range of options. So they could pursue college, STEM careers, or they could go straight into employment in life science factories, life science industry. Ultimately, our goal is to have fulfilled adults who are pursuing meaningful careers in this bioeconomy, and those adults should be equally fulfilled whether they pursued higher education or not through this work. And then this bioeconomy will yield a range of quality jobs, a more diverse workforce, and society will enjoy the benefits of all this technology. So that is our grand vision. We are excited about it. We spend a lot of time working on it. We have been, as I say, at it since 2011. I'll quickly go through a short timeline of how we've reached about 87,000 students over the 14 years that we've been working at this. We began with support from the National Science Foundation to work that I was doing at MIT. We established a 501c3, a nonprofit, to bring this out into the world. In 2011, I ran the very first teacher professional development workshop I had ever run in my life, and we ran it with 27 wonderful teachers at MIT that summer. Many of those teachers continue to do BioBuilder years and years past this 2011 launch of our nonprofit. In 2014, we began something called the BioBuilder Club. It's an after-school program, enrichment program. We did that because teachers were finding it difficult, or they were nervous about implementing BioBuilder in their classrooms and wanted a small cohort of engaged students to start with. And so BioBuilder Club works a little bit like the first robotics club or iGEM. If you guys saw 60 Minutes this past week, they focused on iGEM. BioBuilder Club is an inexpensive school academic year-oriented club for young people who want to design, build, and test biotechnologies. We this year have 80 teams. We have been growing in leaps and bounds. Just 3 years ago, we had 37 teams. So we have doubled in 3 years. So a lot of students, we have more than 500 students participating this year from all over the country and all over the world. This is a very impactful program. Many of the students identify their high school BioBuilder Club experience as the reason they wanted to pursue science, like a biological engineering or chemical engineering pursuit in college. We have a textbook, sensibly enough, called BioBuilder that is published by O'Reilly, and we have some informal engagement activities that we developed with the Museum of Science here in Boston that's largely focused on food and novel technologies. These can be good introductory materials. They're freely available online, and introductory materials for beginning conversations around biotechnology, synthetic biology, and life science engineering. We have been working for a very long time in partnership with the Massachusetts Life Sciences Center, a quasi-governmental organization here in Boston or in the state, in the Commonwealth. And one of the programs that we developed is a workforce initiative called our Apprenticeship Challenge. Next Saturday, we will graduate 21 more students from 15 high schools through our Apprenticeship Challenge program. And they go on to internships. We also now help them test for micro-credentials before they finish. They get resume building skills and interview skills through this program. All right, I'm working through this. We have some teaching spaces that we love. I'm actually talking to you from our space inside of Ginkgo Bioworks, but we have a lab space inside of Lab Central that we opened in 2017. And we have kits that are available for teaching this in schools through Carolina Biological Supply Company. And then two items on this slide that I want to just call your attention to. One is that in 2019, we began a partnership with Eastman Foundation to implement BioBuilder in rural Tennessee. Let's put a pin in that one because we're going to spend the whole last third of this conversation talking about that initiative, right? But in the years since then, since 2019 through COVID, we have a new curriculum called Biotech Builder, which is aligned with micro-credentials. There's lab skills, foundations, and applications, which includes biomanufacturing and synthetic biology. And then just this year, we opened another learning lab at Alston. It is a beautiful space that has students in it actually today and tomorrow. And we host about 800 students a year through our learning labs. All right. So that is a little bit of the history of BioBuilder. We are currently have BioBuilder programs of some sort, teachers or students doing this work in all states. We have those two curricula, BioBuilder and Biotech Builder, that I'll talk more about. We've reached 80 countries, about 87,000 students, and more than 600 teachers we've directly trained. Our aspirational goal is to have this in every high school in America. So we really are looking to expand and to scale, not just grow, but to scale. And we have some ideas from our work in Tennessee about how to do that. So with that as my introduction, I will shift after this to the two curricula that we offer, BioBuilder and Biotech Builder. But can I pause for just a minute and ask, does anybody want to come off mute and ask a question or put something in the chat? I talk a lot, but I really am friendly. Yes, Anna.
Hi, I'm Anna.
Hi.
I'm from the DNA Learning Center, so we do
Oh, hey,
very similar
awesome.
work.
Yes.
Uh, I would love to hear, you had mentioned like an apprenticeship program. I would love to hear a little bit more about that.
Yes. So that is, thank you. And I love DNA Learning Center. You guys do amazing work, especially with Gen Space, and I love them too. So we have an 8-week training program. Students come in from schools all over the area for 5 hours on Saturdays, and then we have 2 hours of online training every week. So after the 8 weeks, they have learned lab skills, they've learned classroom content, they've had career conversations with individuals who are practicing scientists, they've tested for micro-credentials, and we've given them resume support and interviewing practice, and we connect them with an organization called Kelly Science, which helps link them to open opportunities in life science. Sometimes they're temporary that turn into permanent jobs. The curriculum is based on Biotech Builder's curriculum that we've adapted, and we run them in our learning labs. We've had, yeah, lots, like 250 students come through this, and it's really impactful. In fact, both Kevin and Angel, those two young people I showed earlier, both came through our apprenticeship program. Yeah.
Awesome, thank you.
Thank you. Yeah, and they are offered the students earn stipends through the end of it. Some questions from Mina. Is this open to anyone, and is there a price structure for training? Yes and yes. Many of the BioBuilder materials, if you go to biobuilderlearning.org, and I'll talk about that next, is openly accessible and online, the lessons, the PowerPoints, things like that. The kits that we offer are through Carolina, so those are commercial kits for the materials to do the labs themselves. And then Biotech Builder, we have, again, a partnership with Carolina to provide the curriculum and the materials. And I think this week, next week, we're going to have a cost calculator that we push out to give sort of a good, better, best versions of implementation depending on your budget. There are ways to bring this into your school. It can cost nothing if you want to do a biodesign project. That's paper and pencil and connection to the internet. BioBuilder Club is $400 for 6 months and 10 students. So that's $40 a student for 6 months. And then, there's scaling all the way up to, teacher training and full implementation of the whole curriculum. So we have different points of entry and different price points for it. Hope that answers your question, Mina. All right. Let me just talk a little bit about the curriculum, because then I really do want to spend at least I want the high point of this seminar to be the work that we're doing in Tennessee, because I really think that is worth shining the greatest spotlight on at this point. So BioBuilder has two curricula that we offer. It's got the BioBuilder, which is problem-based learning, and then Biotech Builder, which is more skills-oriented training. So I'll talk a little bit about each of them. BioBuilder has programs for students, for educators, and for industry professionals. And our goal is to teach students how to integrate both biology and engineering to design biotechnologies that meet challenges that they think are important. We do this with hands-on lessons through those club activities like the BioBuilder Club. We do school to work activities and practical conversations with career scientists and things like that. Teachers, we have teacher professional development that helps integrate this project-oriented, problem-oriented, engineering-oriented teaching of life science into their classrooms. But Carolina is our distribution partner. They do a wonderful job of putting the materials that we have for the labs into kits. And then when there are issues with materials that you receive, questions, they are the ones that can field those. And we have been really just delighted with our partnership with them. I see them as a very high quality provider of materials. We have done a study on the impact of BioBuilder. BioBuilder curriculum has been sort of our off-the-shelf curriculum since 2011. We've had longer to look at it and figure out how it's working. So we did a study last year, it was published in 2025, February, to ask students how they felt after doing BioBuilder work. And these are questions, and I'm not going to go through each one, but you can see where the neutral line is, that vertical line of neutral. And you can see that the predominant weight of the answers that the students give are on the agree or strongly agree side, that they would recommend the class with BioBuilder, that it supported their interest in BioBuilder, that they're interested in pursuing careers in life science thanks to BioBuilder. So a lot of really good science identity outcomes that we have measured thanks to participation in BioBuilder work. We do teacher training. Teacher training is really where we started, and what I am still perhaps the most engaged in terms of the direct delivery of the content to the beneficiaries. Char was one of my students this past summer, and I'm thrilled to continue to be working with her. And so this is a QR code that will take you to the landing page for teacher training, if that's of interest to you. And then again, the textbook, which was intended to be sort of a self-paced way to learn this. It's really much of our BioBuilder teacher training in a textbook form. Biotech Builder is our newer curriculum. It has 3 modules in it. It's got the lab skills module, which covers lab basics like lab safety. It has making solutions, which covers things like the metric system and moles, and then it has growing cells, which covers things like sterile technique. We also have a module called Foundations, which is divided into analysis of DNA and analysis of proteins. We use one bacterial strain that expresses an enzyme for all of the foundation work. So the DNA analysis component is really asking, do you know that this strain has the DNA in it that you think it should? And so we do, how do you grow the cells? How do you purify the DNA? How do you analyze the DNA to know that it is the correct piece of DNA in those cells? And then with the protein analysis, we induce those cells to make the enzyme, and then you measure the induction, you measure the viability, you purify the protein. So these are foundational skills for research in bio and biotechnology. And then the last module is an applications module where we focus on biomanufacturing and synthetic biology. I think these are the 2 modules that are probably most distinctive about the Biotech Builder curriculum from other curricula that are out there, and really have current workforce needs associated with both of these areas for students. So again, Carolina is our distribution partner for the curriculum and for the materials. And then we have been working to align our content so that the students can get micro-credentials associated with their success in the multiple modules. So we have aligned the curriculum to BCSI micro-credentials, as well as the base exam and their digital badges from Biotility. So these are ways that students can demonstrate their skills, put those skills on their resumes, and then get entry-level jobs in biotech. And again, we have teacher training associated with Biotech Builder. Excuse me, we have lab skills training and then DNA foundations training. Both of those are open for registrations. We're still working on the protein and then the biomanufacturing and SynBio. Those are both slated to come out in 2026. All right, I'm going to pause here. I gave a very quick overview of the curriculum. I want to switch after this to our work in Tennessee, but again, I'll pause just to ask if there are questions, if I've confused people about what the curriculum has, what you might start with, or how to think about it. Anybody? Nope. I won't call on you, so. All right, you guys are just interested in seeing where it fits and what we've done in Tennessee. So I will start. You heard me say we have examples of implementation in all 50 states. Massachusetts, where I am and where our headquarters is a strong toehold in the education, the high school education in this region. But perhaps surprisingly, Tennessee, starting in northeast Tennessee, which is a beautiful area of the Appalachian Highlands, is growing into a world-class bioeconomy. And these are some of the partners and some of the factors that led to our partnership and our expansion there. It began with a grant from Eastman Foundation. Eastman Chemical Company is headquartered in Northeast Tennessee. They sent a cohort of teachers to learn with us here in Boston. We went down and further trained them over the summer, and they have been implementing this curriculum at one of the local schools called Dobbins-Bennett. That work was amplified through partnership with the Niswonger Foundation, a philanthropic foundation in the area that has secured a grant from the Department of Education. How quaint, for expanding that opportunity that was initially offered to teachers through Eastman into more school districts in the area. And that was what led me to have the opportunity to work with Char and other wonderful teachers in Northeast Tennessee. We've had ways of sharing and amplifying our work. We ran a symposium at East Tennessee State University called Growing the Future, a symposium on innovation and education for the bioeconomy. We've had grants from an MII called BioMade, a federal granting and manufacturing institute. We've had a total of 3 grants to help support this work in different ways. One for curriculum, one for that study that I mentioned to you, and expansion through Tennessee, and one to partner with ETSU. We've done that study. And then we had recently the National Security Commission on Emerging Biotechnology come in August to East Tennessee at East Tennessee State University to look at this purpose-built pipeline for biotech education that we have started there and that is now taking hold in its way throughout the state. So what I'd like to do is play a very short video from that visit from the National Security Commission, and then I will turn it over to Char to talk about her experience as a teacher, interacting with all of us who are cheerleaders for this and seeing what it is, how it is playing out for her. So let me first show this video, and then I will turn it over to Char here.
At ETSU, NSCEB leaders spending time looking at how work here in Johnson City connects to the future of biotechnology. From job growth to national security, ETSU leaders say this region is making an impact. Students, educators, local officials, and members of NSCEB all gathered on ETSU's campus for a series of panel discussions focused on biotechnology.
We're surrounded by biology every day, the living organisms around us and the organisms that have now died, and then we do something with them, maybe make materials.
ETSU leaders shared how the region is already making strides in biotech and what's needed to grow even further.
We started this session just with an origin story. How is it that biotechnology has come to our region? Fast forward now to what we call Biotech 3.0, synthetic biology, the amazing things happening.
Panel moderator Natalie Cadell is the founder and CEO of the BioBuilder Education Foundation. She says the goal is to build a strong biotech workforce right here in East Tennessee.
Our goal is to excite this next generation of young people to think about life science as a career.
Some of the job options include scientists, lab technicians, and research associates. Cadell's BioBuilder program has already been implemented in nearly 10 local schools in our region, bringing biotech education to the classroom.
That means hands-on learning. That means valuing their ideas.
The long-term vision to expand workforce development programs across Tennessee and ultimately across the country. At ETSU, Natalia Hillen, News 5 WCYB.
All right, so that was a short news clip from our visit with the National Security Commission back in August. One of those 10 schools that we have implemented in includes the one that Char is teaching in Jefferson County. And I would like to, if I could, yield the floor and have her talk a little bit about the work that she's doing there, the things she has seen with her students, how she's finding it. She will, I guarantee, talk from her heart, and she's a fabulous teacher, so I'm grateful she will share her experiences. Yeah, Char, do you want to take over?
Sure. Hello. Thank you, Natalie. Yeah, I would love to talk about how Northeast Tennessee is implementing not only biotechnology, but BioSTEM is a new class that they're rolling out, biotechnology and bioengineering, biomanufacturing. The focus of the class is on careers, and BioSTEM allows students to go into the lab and have that hands-on experience that I have already seen change their attitude towards being in the lab, what science looks like, how to think and work together, which no matter what they go into as a profession, they need to know how to work together, think through things, have that communication and collaboration skills that I really think is highlighted in this curriculum. I'm very new to it. I just moved here actually from California in January, where I taught chemistry for 12 years and taught middle school and elementary before that. So I've had a lot of years in education. So the way Tennessee does education is a little bit different. So I'm growing to understand how professional development here is very different than in California. And I feel like Biotech Builder brings this layer of professional development that they would not have otherwise. So I'm really thankful to Natalie for bringing that in, because it definitely changed my vision of how I was implementing teaching here without the structure. For example, my high school is just starting BioSTEM, and they did not even have a curriculum. So luckily for them, Nice Longer stepped in and asked myself and then 3 other teachers to help write the curriculum so that students could engage with the science. And then they asked us to learn about Biotech Builder, and I wish they actually had done it in the opposite, because it would have been so much better to start with the Biotech Builder first and then just add in the little pieces, because I'm working with freshmen, and freshmen are different than your upperclassmen. So you have to address their needs and where they're at. And like what community you're living in. And our students in Dandridge, Jefferson County, where they live and I live, it's very rural and there's a lot of farming. So the way they view and interact with biotechnology and farming is very different than Anaheim, California, where I moved from. So understanding and addressing that is where the teachers come in. But I think regardless of the biotech builder, it's universal. So all students can go into the lab and they love the micropipettes. So that was really neat. And it's actually interesting to all of us that have started teaching this, that it's kind of the kids you would not expect are really good at it. And it's the kids that want to become the machine repairmen, and they're very good at hands-on engineering type skills that were really good at the micropipetting, and they just shined. So it's not the kid that thinks they're going to be a scientist, it's the kids that don't think that they're going to be a scientist, that can see themselves in that profession, and see themselves really being appreciated and growing. So I have had a very, very positive experience with it. The BioSTEM curriculum that I designed, I just actually looked at the standards because there is standards for it. And the standards really just called out again for careers and implementation. So I kind of just thought, if you look at the biotechnology industry, it really does focus and highlight, if you look at it through the agriculture and medicine and industry and environmental. Now that I've actually taught it this semester and implemented it, I would change industry to actually forensics, because there's a ton of biotechnology and forensics and the kids love forensics, and industry is really spread out through all of them. So it's not like I would get rid of industry. You're just looking at agriculture and medicine and environment through the industry and how biotechnology has impacted it. And even just small things like GMOs. Students really don't know what a GMO is, and GMOs have a really bad reputation. And just taking the time to, explain to them what is a GMO and how has that actually benefited all of us, and really just giving them opportunities to learn in a conducive and collaborative environment really excites me. So I'm really happy to have this opportunity to share that with you guys. So, any questions?
Shar, you're great. Thank you. Yeah. We hear that a fair bit, this idea that it's not necessarily the students you would think would shine, that when they get into the lab, I mean, the opposable thumb thing really makes a difference for some kids, right? And they do stuff, and
changes their attitude in the classroom too,
yeah.
because they recognize their skills are valuable, and it's not book smart. It's go into the lab and think for yourself and look at what you have in front of you and try to figure things out. So it's been great.
Such important skills, right? Look at what's in front of you, try to figure stuff out, right? And know that you have the capacity, and know who to ask if you can. I mean, I think these are just such important insights and joyful chances to teach. So that's awesome. Yeah. So let me just go to one more slide, and then we'll just open the floor up to other questions. This model in Tennessee is now a template for a national model. The components of this national model, we are collecting into a white paper, and that white paper is at the graphic designer right now, so it will be published very soon. I'm hoping before the end of the year. There's a QR code on this slide for anybody who would like a copy of that white paper emailed to them when it is finalized. But there are really 5 components to the model in Tennessee that has allowed it to become a statewide model, or be the template for a statewide model. First is that there is access to all students through their required freshman biology class. So Char said she's teaching first years. Those biology is a required first year course there, and all students are learning through this portal class, which allows them to then decide whether they will pursue this as career and technical education and go through BioSTEM 2, 3, and 4, or whether they want to continue on the comprehensive path and go through to a standard high school curriculum in science, which includes, more physics and chemistry. It is a clear and coherent sequence of BioSTEMs 1, 2, 3, and 4. There are, as Char said, frameworks associated with each of them, and the teachers have been collaboratively developing the integration of BioBuilder and Biotech Builder into this BioSTEM 1, 2, 3, and 4. Importantly, in the middle bullet here is that there is a sustained funding model for this curricular implementation. The Niswonger Foundation has been fabulous in getting this launched. The Eastman Foundation has been fabulous getting this launched. ETSU has been an amazing partner in getting this launched. But for it to have legs, you need a way that it can be sustained in the statewide education system, and that is through their funding model called TISA, in which career and technical ed students have certain dollar amounts that go to the schools who are teaching the CTE kids. So there is a model for sustainable funding. But none of this would have happened without a real coalition of local stakeholders. So local industry, higher ed, philanthropy, and then BioBuilder as the content expert to bring this in. And so by demonstrating growth and replicability, it is now becoming, as I say, this model for a purpose-built educational pipeline into biotech, whether the students want to go on to college and earn a science degree, become the innovators of future biotechnologies, or whether they want to graduate from high school, go straight to work, and have entry-level wealth building and purposeful jobs in biotech. So that is the last slide I have. I will actually stop sharing my slides and open the floor up to questions. Mina has a question in the chat that I'll take first. How BASE is helping to secure jobs? My understanding is that it is a very general and not specific to biotech. So great. So BASE, just to clarify, is a credentialing third-party evaluator. They come out of the University of Florida, and they have worked with industry partners to identify the skills and knowledge that is necessary for careers in biotech. They have two offerings, multiple, but I'll just focus on two. One is their longstanding capstone exam, which is if you think about, for example, advanced placement biology, you can study for the whole year and then you sit for the AP Bio test. BASE offers a comparable to that, where you can study and then sit for a comprehensive test called their BASE exam. And so that is one offering that BASE has. More recently, they've launched digital badges that are free and that you can practice and take online. We are actually doing a practice exam with our apprentice students tomorrow, Saturday, and they will be sitting for their BASE digital badges the following Saturday, the 13th. So that is how BASE works to evaluate and identify students with particular skills. And then those students can use that qualification to secure jobs. I hope that answers your question. We are not BASE, right? But we have been working with them to try to partner and incentivize the adoption of biotech curriculum. So yeah. All right. Oh, hello, Linnea. Linnea, do you have a question for us?
No, right. Sorry, I had internet problems.
Well, I'm happy to see you now. Do you have any thoughts or anything you'd like to add?
No, I'm very interested in the state model, as that's similar to what we're trying to do too.
I know we can do it. I know we can do it.
The more of us trying to do that, the better off we are in terms of trying to get it implemented. Because so many programs are starting without resources.
Yes.
They're just being mandated.
Right. So, we have a running start at this. We have Ways to de-risk it. I'll just maybe editorialize for just a second and say, I'm a scientist by training and an educator. Running an educational nonprofit was not on my bingo card that I would have thought about, 15 years ago, but I find it incredibly satisfying, but also incredibly frustrating because education is so slow to change. And even when people feel like what they're doing isn't serving either the teachers or the students or the community well, getting new material adopted is tricky, and people fall back to habit and anxiety about what they've been doing. And I understand it, but I think finding ways to partner to de-risk the adoption of something that is shown to be effective and is known to do better is going to be an important part of the answer to developing a bioliterate country. I started this whole hour by saying how important education is to the liberty and foundations of our country, and bioliteracy is really going to be ever more important for national security and then also for workforce.
I'll just add to that is when I started 30 years ago and I got involved with education, moving from research to education, I was really surprised at how much politics were involved with education where it should not be. And then also the mandates for funding sometimes are not appropriate in that, and then teachers are forced to do things that don't necessarily promote learning. Like, I'll just tell you, our Intro to Biotech course that's in high schools and in our 2-year program, I've told my dean that I wouldn't be surprised if people do drop out. It is made to be an introduction to biotechnology, and biotech is important, but if a student is not interested, they drop out. It is the one course that we do see that happen, and that's all right in my mind. And then the rest of the program, if they decide to stay, then I have 100% that stay. So,
Yeah.
but the school goes, no, that's really bad. And I'm going, well, if someone is not interested in it and does not want to stay, it's not really, and maybe you could say I'm not doing a good job of making it interesting, but sometimes people make choices. So I think you have to allow for choices too.
Yes. That's some of the I think really smart planning associated with the BioSTEM that the Niswonger Foundation has done, is that first year course gives students optionality to either continue to pursue through BioSTEMs 2, 3, and 4 and become completers through the CTE pathway, or to have credit for that class as curriculum that satisfies general education for a high school diploma.
And that's one thing we worked hard was to get that course in Texas. It used to be a workforce course, and we worked really hard to make it a science course. Otherwise, our high school students wouldn't even take it.
Yeah.
So,
yeah. Yep. Well, we may be preaching to the choir here, but I do think there are ways to crack this. So, are there other folks on the line who have a question?
I just want to say you have really great material, and I am very sorry I did not get to start off with all of you. I was not expecting. The internet was working this morning.
That's okay.
And then it went out.
My understanding is that this will be recorded, and you could watch it on 2x speed, which is probably the better way to watch it when you're here.
So did you get to meet Anna? Anna works at Cold Spring Harbor DNA Learning Center.
Yes, indeed.
Okay, good. Because I didn't know if everyone introduced themselves at the
She
beginning.
did not. Anna came off mute. She bravely did. Other people, if they would like to introduce themselves and say where they're at, would be great.
Yeah. Because it's always worthwhile. So did you meet Dion and Cassandra, though?
I did, of course.
Okay, good.
All right. So I'm going to call on Sarah, Jury, since you're on video, and
don't be shy.
Be shy, yes.
Yeah, we don't bite.
Hi, how are you? My name is Sarah Jury. I'm with Biomed SA in San Antonio. And I was really excited to jump on this call. I'm in an interesting position in that I am a former educator and now work in building ecosystems in the biomedical space. So I was really excited to hear about the program and the micro-credentials. And from our perspective, our biggest challenge is engaging our industry partners. We want to prepare our students well, and I'm looking to the landing spot. How do I bridge that gap? And if there's any successes or best practices you can share, I would love to hear them. I'm the university liaison here in San Antonio with Biomed SA, and also work with the hospital systems and the startup community. And so
That's great.
there's
I
a,
mean, I do want to meet everybody, and I know we're running close on time, so I will
oh,
just
sorry.
quickly do the, no, I'm really glad you asked. I'm really glad you asked. So I will just say two things. One is that these micro credentials that the students have and can put on their resume will help them in college as well. We've had a student write back to us and say that as a freshman, a first year student at a college, she got into a laboratory position because she had those micro credentials on her resume, and the PI recognized her abilities. She said normally he only takes juniors and seniors. So there is a way that these credentials help accelerate students through the college pathway and research as well. But your question really was about industry. And so with our apprenticeship program, we are working with Kelly Science and Clinical as a placement agency to get to know our students, get to know these credentials, and they have open opportunities for young people or for, young entry-level scientists. So Kelly Science and Clinical, we're not a placement agency, but we do. I mean, we're fortunate in Boston, right? We have a fair bit of biotech, but yeah, I think that's an interesting connection to pursue as well.
Thank you. I appreciate your time.
Sure. Megan, do you want to introduce yourself?
Sure. Hey, y'all. I'm Megan Heafy. So I work for Georgia Life Sciences in our Office of Workforce and Talent, running the Biotech Teacher Training Initiative and Equipment Depot here in Georgia. So here to listen, and Anna White made an intro email while you were talking, so we'll be chatting soon. So, yeah, happy to stay plugged in and keep sharing your information with the Georgia teachers and continuing to grow our team number and share all the things.
Thank you. Linnea, you were brilliant to ask for people to introduce themselves, because we have, New York, and we have Texas, and we have Georgia, and that's brilliant. And for those who have not seen it, 60 Minutes on Sunday ran a piece on the Georgia students in Lambert High School who went to the iGEM competition, which is a international competition in biotechnology. It was a lovely piece. 60 Minutes did hours and hours of videotaping, including many of our BioBuilder clubs in the area. We have a lot of adoption in Massachusetts. We have a lot of adoption in Tennessee. I would say the third and really close behind Tennessee is Georgia, because we have 25 BioBuilder club teams. That Lambert team from 60 Minutes, they have 100 applicants for their 10 positions on that team.
Oh my gosh.
And of those 100 applicants, of those high school students, they do 3 BioBuilder club teams for the other top 30 who didn't get onto the iGEM team, but they do 3 BioBuilder club teams. That's the program that we run, which is $400 and 6 months, and we get scientist mentors, and we run a final assembly here in Massachusetts for the students to present. But this year, Georgia, thanks to Anna White, is going to also be running a final assembly in March where the students can present their work and publish their work. So yay, Georgia. Very excited about all that's happening there. And Megan, yes, we will chat more.
Well, I know you're going to bring in Aaron. Aaron Kamajaya is like an amazing person, but
Aaron, come on in. Who are you?
I think we met before in 2021. I think it was in the race against the clocks in BioBeta conference. I brought 8 students there, and that's the first time I learned about BioBuilder. I'm from Los Angeles Pierce College, California, represent. Yeah. So yeah, I mean, I'm right now interested in the club. Right now we have very strong biotech club, but we just need to do sort of like we don't have a lot of resources, so we just use whatever we can get. So
yes, yeah. So BioBuilder really is set up for places that are, I mean, certainly we have lots of well-resourced teams in our BioBuilder community, but we also have schools and areas that don't have the same resources. I mean, one of the big takeaways from that Lambert High School piece in Georgia was that is an extraordinarily well-resourced school, right? They have an incredible lab set up there. Anna White's is not the same way, and yet she has thriving BioBuilder Club teams. Aaron, I'm thrilled to hear that you have a lot of activity there too. The lab setup, I really do think there can be a good, better, best, and that the student outcomes don't depend on whether there is a good, better, or best lab setup for all. So, Aaron, that's great. And I may be coming out to SynBioBeta again this year for a bioliteracy summit that's out there. So, yeah.
So I will quickly say that, we're always supposed to bring a student to the ATEPI meeting, and Aaron knows about that and others. I like to bring students that aren't necessarily part of an ATE, or they're just part of the larger community. If a BioBuilder does a fairly good poster, we could actually think about Aaron. We could bring them, because I think they'd be a whole nother audience to bring, is not just the students that are in the classroom who are doing undergraduate research, but maybe a BioBuilder.
Sounds great.
And that might be worthwhile. So
we have a lot of extraordinarily talented students who are publishing their work and would make great. We require a poster as our BioBuilder Club final project.
Yeah. So, I mean, obviously we need to talk more about that, because there's so many different ways to get people involved. And this would be another way to get to parents too.
Sounds great. Sounds great. All right. We are quickly coming up to the top of the hour. Linda Lee, if you are there, would you introduce yourself?
Yes. Hi, Natalie. Hi, everybody.
Oh, Linda. Yay. Good to see you.
Good to see you.
Massachusetts is in the house too.
Yeah. I saw this, Natalie. I'm like, I need to go and listen, because it's amazing. And we are happy to be partners and be able to help you achieve everything that you do. So my name is Linda Lee. I am the director of the Educational Partnerships and Workforce Programs at the Massachusetts Life Sciences Center. So we are the arm of the state that funds everything related to life sciences.
Yes. Linda, Linda's amazing. Mass Life Science Center, BioBuilder would not be BioBuilder without Mass Life Science Center. They've been in it lockstep, shoulder to shoulder with us from the get-go. And you guys are amazing. They sponsor the apprenticeship program that I was talking about with you, Anna. So that is how we are able to offer stipends to the students, right? We're a nonprofit. We don't, so they support us in so many ways. We just built out that Alston lab together. So it was great. Thank you, Linda. Great to see you.
No, as I like to say, and I know I learned this from Brian, we do the easy job. That is just give the money, right? You all do the hard part, which is being there and teaching these kids and developing everything that you do. So thank you so much.
Thank you, Linda. That's awesome. All right. Marilyn, Edmund, do you want to say hi?
Hello.
I am so sorry. I'm having technical difficulties. But my name is Marilyn Edmond with Dallas College. And my position at Dallas College is Continuing Education and Workforce Coordinator. Thank you so much for the information, and I look forward to the recording.
Oh, good. Thank you,
Hi,
Marilyn.
Linnea.
Hi. All right. Texas, everybody knows everybody. All right. And does that leave Mina? Are you the person calling in from a phone?
That's Russ Reed. He's part of
Ross. Ross, great to see you. Great to hear from you. Good.
Well, I almost feel like we should do another half hour, especially.
But it is Friday. So we will let everybody go. Char, thank you especially for rushing home from school to be able to do this. Thank you very, very much.
Oh, thank you for having me, and thank you for all the great information. It's great to see in so many places that what we're doing is not just us. Sometimes, you feel isolated, but I do want to give you one plug. You guys should all come to her once a month. It's a biotech community meeting, and she's fabulous. She always talks about relevant things. One month she talked about students' amount of sleep and their academic, performance, and it's things as an educator you don't necessarily think of directly. So I love that. Chloe can, I'm sure, hook everyone up with when it is and all the details because Chloe's
we'll gladly advertise that at our website and put it in our newsletter. And I'll gladly come knowing that too.
Great.
It's
Yeah.
fun.
Your community
Just give
practice.
us that information.
Yeah. Great.
Yeah.
Will do. Will do.
And don't forget about our holiday giveaway that's going to be on the 11th. Okay. And Natalie will be back for that.
Yes, I'll be giving some BioBuilder textbooks will be given away. So yes.
Nice.
Yeah.
Very good.
Awesome.
And I'd like to thank you again, Natalie. Your presentation, the data that you provided was extremely helpful. We could see it all. We could see the importance of it and also the examples for that teachers can just use this right away. Char, your testimony, is spot on with your perspective and hearing how students respond to this. It really proves that it's a doable curriculum. And then also, as we mentioned earlier, we will post the slides and the recording on the Innovate Bio website by early next week. And if you're not already, which I'm sure everyone's names looks familiar, please be sure to join our Innovate Bio website community. And I will drop, actually, Cassandra dropped the registration link to the holiday giveaway next week. And also we will, on that link, you will see an opportunity to join our community. And again, please, Natalie, share the link. And we will include that with the recording. And as Linnea mentioned, we will include you in our newsletter as well.
Yeah.
But thank you, everyone. I appreciate you being here on a Friday afternoon. And we wish everyone a fabulous weekend.
Yeah. Thank you.
Thank you.
Thank you.